Hi everyone, how are you? Hope you're enjoying your DLD. So I want to do a quick video on parabolas or parabolas. And I'm going to kind of do two problems from the sheet that I had you guys do today for DLD. So a parabola, what is a parabola, right? So a parabola is like a quadratic function. So we've got four different ways that they can look, right? So they can look like your typical quadratic function, right? This would be, and again, I'm just estimating what it looks like. Y equals x squared. Obviously opens up. Okay. We can have our reversed quadratic where it will be y equals negative x squared, and obviously it opens down, right? Because it opens down, right? And then our new two ones that we're talking about is when we have x equals y squared. Obviously the square is on the y. Now that's positive, so that quadratic, so to speak, is going to open to the right because it's positive, right? And then the other one, our last one, will be when it's x equals negative y squared, and the negative would be that reflection, and it would open to the left, right? So these are the parabolas that we're talking about, and it's important to know how they open so we know what to do with our focus and directrix, right? So that's where we are. Okay, now let's do a couple problems together. And we also would know far better what the axis of symmetry would be for these things, right? So let's take a look at that first one. So the number one on your work today was y equals negative x squared minus 8x minus 20. So it's asking you for four different things. Well, really five to graph it, but I'm not going to graph it on here. So it's asking for the vertex. It's asking for the axis of symmetry. AOS is how I'm going to use that from now on. It's going to ask for the focus, and it's going to ask for the directrix. Okay. Two things to remember about the focus and directrix. The focus is always inside of the parabola, and the directrix is always outside. And the important thing about both of them are they are the same distance from the vertex. Same distance, I should say distance. So they're the same distance, they're equidistant from the vertex, just the focus is going on the inside of the parabola and the directrix is going the outside. All right, so let's go ahead and find the vertex. Now, the vertex when we have an x squared. The formula is going to be negative b over 2a, comma, whatever that function's value is at negative b over 2a. So for example, we're going to have our quadratic function. A is the first number or the coefficient. B is the coefficient of the x in the middle, and C will be the last term. So we're just going to follow the rule and plug in what we know, right? So for this particular function, negative b is 8 because b as it stands is negative 8, right? So I have to negate that sign. So our value here will be 8 over 2 times a. Well, a is negative 1, right? So I'm going to do 2 times a, so that's going to be negative 2. Now, 8 over negative 2 simplifies to negative 4, which means our vertex, the x value of that vertex is negative 4, okay? Now, this whole f of negative b over 2a, that just means I'm going to take the negative 4, which was the x value, and plug it in to all the other x values. So I'll write that out here. That'll be negative 4, because remember, the negative sign was in front, squared, minus 8 times negative 4 minus 20. Hopefully you can still see that. Okay, good. So I'm just going to evaluate this. This will be negative 4 squared is 16, then negative 16. Negative 8 and negative 4 is positive 32, minus 20. Negative 16 plus 32 is 16, minus 20 is negative 4. All right. We have our vertex finally, and our vertex is negative 4 comma negative 4. All right. Let's do this in some different colors to make it look a little bit nicer. All right, let's go ahead and find the axis of symmetry. That is the easiest thing to find here. The axis of symmetry is going to be a line, and when we have an x squared, meaning it opens up or down for that matter, and this is going to be opening down. So we're going to have the line x equals and the x value of its vertex, right? Because it's going to be that dashed line, that hidden line that goes right through the x value of the vertex, right? So that's going to be our axis of symmetry. Let's go to the focus now, okay? This yet still unnamed thing that we don't know what it does, right? So focus. Focus! That was funny. It's not. Hey, that's not funny. That wasn't funny. Okay. Now, it's important to know how the parabola opens. Obviously, this is going to open down, but that doesn't matter either way because up or down, whatever. So the focus here, the rule is, because it's opening up or down, is remember that whole rule about HK, where that's the center of the circle? Well, HK is the vertex. That's just another way to put vertex. The H, the X value, isn't going to change. Because this thing opens up or down, it's the Y value that's got to shift up and down, right? So this is going to be, the K value is going to be the thing that we add or subtract that 1/4 A times. So the focus for this particular function is going to be H comma K plus 1 over, now this is going to be the change from what we talked about yesterday. We're actually going to put the A value in the denominator with that 4. We're not just going to multiply it to the side like we had talked about before yesterday. We're going to put it in the denominator, and the reason for that is going to be a little tricky to explain here in this video because we're already at 6 minutes. Just take my word for it, it's going to work. All right, so here we're going to put our values back in. So our H value or X value is -4. Now the K value is also -4, right? Now I'm going to add, because the focus is going to be plus, because I'm going to have to add to it, right? And it's going to be plus 1 over 4 times the A value. And that A is that A, right? So it's going to be 4 times -1, okay? Now, what does all this mean? Well, it just means that I'm going to have to do some calculation. So this will be -4. It's going to end up to be, because I don't want to run too long here. -4 comma -17/4. This is the focus of that parabola, right? Because it's going to be inside of the parabola. Yeah. Okay. Now, the beauty of this is if you know the focus, you know the directrix. And the reason we know that is because, remember how I said earlier in the video that the focus and the directrix were equidistant from the vertex? They have to be the same distance away. It's just one's on one side and one's on the other. Well, algebraically speaking, to find it, it's going to be H comma K minus 1 over 4A, right? Because the plus is going to make it, yeah, and the minus is going to make it, yeah. Okay, now, this value here was 1 over 8, like 1/8, right? Or no, 1/4, it was -1/4. So if it's -17/4, I'm sorry, I'm doing two things at once. If it was -17/4 and the Y value is -4, right? So then we're just going to go the other direction. So the directrix will be -15/4. So we're going to have a -4 comma -15/4, right? And then algebraically, what this will look like would be K minus 1 over -4 or K plus 1/4. This was K plus 1/4 straight up, but this one's going to be the K and that negative that we have to cancel out. Okay. All right, let's do another one. Let's erase some stuff. I'm going to keep that there for another 2 seconds. Okay, that was fun. All right, let's go over here. All right, let's do number 3. Because 3 is going to open up differently. The light's different over here. It's fun. Okay, so number 3. Okay. Number 3 is x equals 2y squared minus 4y. Okay, now we're certainly very different here because now we have a y squared, right? And the y squared means automatically that we're going to open up either right or left. It's positive though, right? That's not a negative value, so it is going to open up to the right. So it's going to look like this. And I'm just drawing it, but it doesn't really go there. It just, that's how it looks. Now, that's going to change the axis of symmetry. It's going to change how we use the focus and directrix and what we apply it to, right? But here's the cool thing that one of you actually found out. So thank you for that. It's very cool. Very helpful. The vertex, we can't actually use this same formula. I mean, we're going to, but it's just going to flip. And we can't use the same formula because the y's and the x's are different. But here's what we're going to do. And again, thanks to you. This makes it a lot easier for everybody. To find the vertex when it opens up right or left, it's actually just that negative b over 2a thing reversed. So it's going to be the function's value at negative b over 2a, comma, negative b over 2a. So we don't really want to find x first here. We want to find, technically we want to find the y first because it's the same way. We just reverse it. So remember that this is a and this is b. C doesn't exist in this problem. It's 0. So, I don't know if you see that. A and B. Okay. So negative b is 4 over 2 times a, which is 4. which means the y value of this function's vertex is 1. So now I'm just going to reverse the process, and I'm going to plug in 1 to both y values and solve. Well, if I plug in a 1 here, 1 squared is 1, and 1 times 2 is 2. And then a 1 here is negative 4. So 2 minus 4 is negative 2. See how easy that was? Thanks again. Really, really helpful. Now, axis symmetry, we just have to be careful about how we use it. You know, we're opening up to the right, so the axis of symmetry can't be an x line. It has to be a y line, and it's going to be the y line of whatever the y value is, right? Because that makes sense. So it's going to be y equals 1. That's the axis of symmetry. And I'm not using a different color. I'll change it now. I'm sorry. Let's go to orange. Hopefully you can see it. Okay, let's go to focus and directrix. So the focus and directrix is going to be the same exact process, right? But instead of adding the 1/4 a to the k, I'm going to add it to the a, or the h. Not the a, because that doesn't make sense. I'm going to add it to the h because that is the thing that's shifting. Remember, h is x, right? H is x, so that's what's shifting back and forth. So I'm going to add that to there. So for focus, that's going to be my new joke in class. To find the focus is going to be h plus 1/4a comma k. Right? So again, our vertex is here. So it's going to be negative 2 plus 1/4 times a. But in this particular problem, a is 2. So that's going to be times 2 comma 1. Right? So when we get it all together, it's going to be negative 15/8 comma 1. That's the focus. And then again, the focus and directrix are the same distance from the vertex. So our directrix is going to be negative 17/8. Now, the thing about the directrix is we actually, the way that it puts it here is it wants to put it as a line. We'll talk more about that in class. So directrix for y lines, we're going to make them actually lines. And the directrix is going to always be the x equals line. So x equals negative 17/8. We'll talk more about that in class. But directrix for these things, they have to be lines. Silly. Okay. Wow, 13-minute video almost. Wow. So hopefully we're there. So parabolas, right? Right? Have a nice weekend.